Alright, bro. I'm on a different computer. Justin done booted me out of my room, but we're chill, so it's whatever. Yeah, I'm in the living room now. I got the motor. Normally he runs it there, but like whoever's watching it. You done took them.
Hey, can everybody hear me okay? Just so I know before I get any farther in this. Hear me okay? All right, thank you.
Shut up.
You're just angry that I'm at your computer and
Took my
you're
fucking
your ass in the
bro.
kitchen.
You done demoted me, yo. That's crazy.
Okay, I'm gonna mute Kevin then.
I dare record, bruh. You're always doubting me.
For good reason.
Oh, bro, I recorded every other time.
Okay,
Terrible
thank you.
person, bro.
Hey, that was uncalled for. Let me see.
Dude reacts to Mr. Ratburn from popular show being gay.
Hey, what are we looking up?
No, you said that to me, bro.
Let's see what I can do on this computer.
Bro, do not search up big dudes, bro. Don't do that. Don't do that shit.
I can do whatever I want on this
Nah,
computer.
bro. Don't do that shit. I should have locked you down. I should have locked. Yo, watch the camera.
Welcome, everyone.
Justin, watch the camera still not. Watch the camera still not work.
It did. I tested it out.
No, you didn't. Turn it on right now. Let me see.
Well, I don't want to turn it on now, because then I gotta switch it back.
No, you don't. Just turn on the camera.
Is he? You'll see it in a second.
Bro, you're
All right, we'll give it a couple more minutes. Let's see who's here. There we go. We got some new people who joined the class too, which is good, but unfortunate because I sent them the recordings of the previous classes, which is total to like 4 hours.
It's actually 3.
No, because we went over a couple of those days. Oh, look, there's water up here.
Bro, that's mine, bro.
You did his water. It's like 50 cents.
Bro, fuck you. You a bitch.
He is in this meeting. Admit. There's a kid. Oh, never mind. That's his profile pic. All right. How's everyone today? Ethan, Kevin, I don't.
You stole my room.
Yeah, well, he's bad. Not the good kind of bad either.
How you know about that?
All right, as we're all trickling in, let's turn on our cameras if we can, just so I can see faces and not avatars. If your camera's broken, it's fine. If your camera's broken, though, I understand. Mine's is broken half the time. That is irrelevant. Combustion was last class, not this class. And Aaron's not here today to mess you up, Ethan. There's nothing on this. It is. All right, we'll get started. Welcome back, everyone. We made it to lesson 4. That's amazing, right? Nobody's dropped the class yet. Okay, so we're going to get started. Maybe get another minute, get that last few people in here. I'm in a new room today. Check it out. I took over Kevin Sen's room to try out my new document camera. So isn't this great? I get to use his computer too. I get to sit on his special gaming chair, like those 1,000-pound sister show, and just sit and do nothing. Or Jazz Jennings. Anybody ever watch that show?
I fucking love that show.
And the best part is I'm using his computer, which means that immediately after this meeting ends, I get to go on these extremely illegal websites and mess up his search history.
All right, bro, chill, bro. Chill.
I was joking, maybe. All right, so here we go.
What you've been looking up before.
Sriram is here. All right, that's 9, 10, 11. No, that's just me. All right, let's get started. Anyone have any questions before we start about anything? Anyone do anything nice today? No? Oh, well. Microphone, speakers. Oh, wrong button. All right, check this thing out. Can you guys see it clearly? Or is it blurry?
It's perfect.
Is it good?
Yeah.
Why does it look blurry on mine?
No, it's actually good.
Really?
Like, on God.
Oh, okay. Now I see it. All right. As long as you guys are good, I don't care how I can see it.
On Allah and shit, bro.
All right. So we're gonna review one problem from last time. Last time we talked about limiting reagent and combustion analysis. So we had some homework problems. I hope we had a chance to do them and upload them. Otherwise, the list is building. All right. So we had one problem that started like this. We burn 1.621 grams of whatever that is. We're trying to figure it out. And we get this much carbon dioxide and this much water. Anybody want to offer what they got as an answer?
I didn't do it.
Yes, you did.
I got C2H6O.
All right. C2H6O. Sounds reasonable. Do we agree? Disagree? Anybody? Someone wants to join this call. Oh, who's that?
Ram Gunapar!
Ram Gunapar. Yeah, we just talked about him. Hey, everybody remember Ram here is Ram in the flesh and blood. We just talked about him last time, right?
Yo, that's crazy. That's crazy.
His girlfriend beats him.
Bro.
That's for after class. Okay, now let's get started. So, as we remember, our first step in any of these problems is to get everything into moles. So, step 1, we're going to use CO2 to find the amount of carbon. So, you have 3.095 grams of CO2, and if at any point we get lost, please feel free to stop me. Times the molar mass of carbon CO2, 44 grams in 1 mole of CO2, times 1 mole of CO2 is 1 mole of carbon. I plug this into our calculator, and that gives us 0.07 moles of carbon. Step 2 is to find oxygen. This is find carbon. This is find oxygen. We start with 1.902 grams of H2O. Multiply by the molar mass, or divide by molar mass, 18 grams in 1 mole of H2O times 1 mole of H2O gives us 2 moles of hydrogen. Plug that into the calculator and we should get 0.21 moles. We all got it? So far, so good. Step 3, find oxygen. This is the tricky one. So we get the amount of carbon we have, which is in moles. It's still in moles. But I will switch colors for the purposes of equity and equality in this society. 0.07 moles of carbon times, let me look up the molar mass, 12 grams of carbon times 1 mole of carbon gives us 12 grams. 0.07 times 12 equals 0.84 grams of carbon. And then we take hydrogen. 1 mole of hydrogen is equal to 1 gram of hydrogen, which is 0.21 moles hydrogen. We start with our starting amount, 1.621 grams. Subtract the amount of carbon. This is carbon. Subtract the amount of hydrogen. And that gives us, got about 0.571 grams of oxygen. That sound about right? Oh, great. I'm off the screen again. You guys can yell at me if I'm off the screen. Feel free to yell at me. That's lovely. All right, let's see. So now we want to get this to moles of oxygen times 16 grams of oxygen, or divide by 16. And we get, divide by 16, 0.0357 moles of oxygen. So we go down here. I'm going to write everything out so we are all on the same page. 0.07 moles of carbon. 0.21 moles of hydrogen. 0.0357 moles of oxygen. What's the smallest thing here? Gee, this sounds familiar, doesn't it? What the fuck is this?
You damn good to par. Scrub everywhere.
Anybody want to tell me what the smallest thing they see is?
The oxygen.
Penis.
Oh, this is. Yeah. Let me see. What's the? Oh, yeah. Well, sure. What's the second smallest thing then?
0.057357.
Yes, moles of oxygen. Exactly. So we have divide everything by the smallest. We get about 2 times as much carbon. And when we divide the hydrogen, we get about 5.8 times, which rounds up to 6. So we get CHO, 2 carbons, and 6. Any questions on how I got that? All right. Let me know if you have any questions. So hopefully we were able to learn something, not that Ron vigorously scrubs himself in the shower. All right. So today, actually, that was a good segue into what we're doing today. Because today, we are talking about fluids and liquids. And he was showering. Right class, I guess. All right, so I want to start out by looking at this problem. Let's take out our Unit 4 or Lesson 4 packet. It says molarity on it. Now, the first problem is, how many moles? I have 2.5 grams of NaCl. How many moles do we have? Let's do that all real quick in a minute or two. And someone yell it out when they get an answer.
.04.
Yo, I got 0.04.
Who said that?
Rom, good to pour.
Ram, we're asking about the moles, not the length of... Oh, wait, yes, that's right. Moles. Yes, correct, Ram. 2.5 grams of NaCl times the ratio. So 58 grams of NaCl, 1 mole of NaCl, which gives us 0.043 moles of NaCl. So just like what we did the past couple of weeks. Now, let's look at the next problem though. So in this problem, we started with grams, which is a solid. And it literally means you go into a laboratory, you open a jar full of powder, and you scoop a certain amount of powder onto a scale. And that gives you the grams. But what if we were measuring in liquid? What if we were measuring in fluid? How would that change? So let's look at the next problem. Problem 2. We have 0.25 liters of NaCl. How many moles do we have? Let's try to do that out. So we always start with what we're given. So we want to get from liters to moles, 25 liters, and then we have to multiply by a ratio. But here's the thing. What do we use for our ratio? We can't use the molar mass. The molar mass is 58 grams per mole. We can't do that because none of those units line up with liters. None of them can cancel. So we can't answer this question without knowing additional information. So we need to introduce additional information, and that's exactly what we're going to do right now. I need the water first. Kevin's personal snack bin.
Bro.
You know, this desk is missing the Diet Coke button like Donald Trump had at the White House desk.
Bro, I brought those bottles of water earlier up this morning, man. Like, I'm 600.
Oh yeah, I bought those as well recently.
Yeah. I'm 600 pounds. I can't get up the stairs.
All right, so now you should put you on TV if that's the case. We're going to talk about molarity. Molarity is abbreviated with a capital M. Molarity,
Sounds like
by definition, molarity equals moles of solute divided by liters of the solution. So now let's picture what this looks like. We have a jar, a beaker, with some water in it, or whatever fluid, and we have little stuff thingies, little snibble thingies dissolved in it. The moles of solute. So solute talks about the thing that's getting dissolved. The solution is talking about the whole thing. The whole ass thing. So the moles of solute is talking about these little black spebbles thingies in our solution. And then the solution is talking about this whole ass thing here. So it's a ratio. Molarity is basically concentration. So when you're making, I don't know, Kool-Aid, you can either put 1 spoon in, like a normal person, or you could be Jazz Jennings and dump the whole ass bottle into 8 fluid ounces of water. It's so the concentration is what changes.
Don't forget the estrogen too.
So we're going to talk about notation here. When you see something like this in brackets, that means the concentration. This means concentration. So I'll give you an example. If you see this, and this might look familiar for those of you who took AP Bio. This means concentration of hydrogen. It's the concentration, not the amount. Amount just talks about grams or kilograms. This is amount per unit of fluid. So this is molarity. So if we go down to our next example here, let me move this thing up. So when we use molarity, we can use it to set up stoichiometric ratios, just like molar mass. So molarity is kind of like the analogous of molar mass when we're working with fluids. If we're told that we have a 10 molar solution, and this might sound familiar, because for those of you who took AP Bio, did you do the potato lab or the apple lab?
Oh yeah, Janet Harper Belleville actually went over that one.
And you asked what a mole is, and she was like, "That's chemistry. Don't ask that."
Yeah, that's what she told me.
Yeah, you know why? Because she, I can't say it. I'm sorry. I'm sorry. I can't say it. I can't say it. Think it, don't say it. Just like Mr.
This
Webb.
is a safe place.
You see, I don't want to say anything that might be considered like culturally and socially unacceptable. So, okay, we have a 10 molar solution. Sometimes we might see this abbreviated as 10M. This M just means more. This just means molar, 10 molar. When we have a 10 molar solution, we can write it as 10 moles per 1 liter, or 1 liter over 10 moles. It's exactly the same as molar mass, except this time we're working with liquids instead of solids. So I'll even put it down here. Molarity is used when we're dealing with liquids or fluids. Molar mass is when we're dealing with solids. Any questions so far? I want to make a point. There is a big difference, and it will matter in the next couple lessons.
You talking Jazz Jennings big or like Simpson?
Aren't they the same size? There is a big difference between moles versus molar. Moles, which is abbreviated as MOL, is what we've been dealing with so far. Does anyone remember what the definition of a mole is?
It's like Avogadro's number. I'm pretty sure.
Avogadro's number? Yeah, I didn't teach it that way the first lesson. That's okay. Anyone remember what that special number was?
6 point something.
6 point something. 6, yep. 6 times 10 to 23rd things.
I knew that.
I see that number every morning when I step on the scale.
Yeah, essentially like mg cosine theta.
MG.
This guy got a 1 on the physics exam, by the way.
Yo, bro, he's lying.
All right. So anyway, let's get back to chemistry. So we have 6 times 10 to 23rd things. That's the definition of moles. It's talking about the particles. When we have molar, that refers to the molarity or the concentration. And what that is when we take the moles and we divide it by how many liters we have. So there's a big difference between moles and molar. And like I said, molar is abbreviated as M, capital M. Moles is abbreviated as mole. All right, so like I said once, and I said it once, I'll say it again. When we're dealing with solids, we use the same steps that we've been doing in the past. It's the same thing. But if we're dealing with liquids, we're going to have to use molarity. And I'm going to show you how to do that right now. There's a different set of rules, but it's a similar concept. All right, so let's look at our first problem. How we doing so far? Okay. All right, let's look at our first problem. It's on the next page. You have 0.265 liters of 0.1253 molar FeCl3. How many moles do you have? So, I'm going to show you how to do this. There's 2 ways to do it. Oh, welcome, Audrey. Welcome to chemistry. So we want to get all of this into moles. So there's 2 ways to do it. I'm going to show you the first way. The first way, way 1, is using stoichiometry, which means we turn the molarity into a conversion ratio. So if we're told we have 0.1253 molar of FeCl3, that means we can write it as 0.1253 moles of FeCl3 over 1 liter, or we can write it as 1 liter over 0.1253 moles. So to do the actual problem, what we're going to do is we start with what we're given, as always, 0.265 liters FeCl3, and we multiply it by a ratio to get us to moles, to cancel out the liters, just exactly the same way we did as the first lesson. So we have liters on top, so we want liters on the bottom, so we're going to use this ratio. We put 1 liter on the bottom and 0.1253 moles FeCl3. I hope you guys can see that. The liters cancel out. We plug this into our calculator and we're left with moles. And that gives us 0.033 moles of FeCl3. Any questions on the first way? Here's the second way, way number 2. And the way number 2 is to use the molarity formula. So we already know that molarity equals moles divided by liter, right? So this is going to be using basic algebra and solving for x. We know the molarity up here, so we can plug this into this. And we know the amount of liters, so we can plug this into this. And when we do that, we only have one unknown left, so we can just solve for x. So the molarity equals 0.1253, well, that's the molarity, equals the moles. We don't know that, so we'll call it x divided by the liters. And now it's just solving for x. I'm going to multiply. I'm not going to insult your intelligence by showing you how to solve for x. And we get 0.033 moles of FeCl3. So we got the same number both times, which means it must be correct. So you guys can pick whichever way you prefer, but generally I'm going to use the first way. But just so you know, in case you see on answer keys or Miss Powell does it one way or another, there are 2 ways to do it. Any questions? All right, let's do a problem.
Yo, I don't think Satvik seems very focused on the lesson. Satvik, his eyes are darting everywhere. He's not very focused.
Oh, I know Satvik. He wouldn't do that. He teaches biology, which you guys should attend his next lesson, which is, when is it, Friday, Thursday? Oh, today's Thursday.
Yeah, it's tomorrow.
Tomorrow? Oh, man, I'm at work tomorrow. That's
No, Ram, I was too distracted by you taking a shower.
Which is on the recording.
More of that.
Which is on the recording. Wait, Ram, how old are you? Ram, how old are you?
I'm 17.
Fuck, now I gotta delete the recording. you see what happens during the... Why couldn't you be 18?
Yo!
Okay. Nobody missed the... I hope nobody missed this class, because the recording's not...
Oh, we're still running, bro.
Now we still run it. I won't say.
Okay. See, I mentioned that these things record, but I never expect someone to take a shower in the middle of class.
No, trust. I won't snitch.
His dick wasn't out of school.
Bro.
All right, so we have 2.6 liters of 1.44 molar HCl, and we want to find how many moles of GaCl3 do we have? So here's the thing when it comes to molarity. As soon as we get to moles, the steps are the exact same as we did before. Molarity is just another bridge to get us to moles. So we start with what we're given, 2.6 liters of HCl. We want to get to moles, so we multiply by 1 liter has 1.44 moles of HCl. There was our bridge using molarity. And now we look at our formula, we see there's 6 HCl and 2 GaCl3. So we just have to arrange it so the units cancel out. So we'll put HCl on the bottom, 6 mole HCl, 2 mole GaCl3 up here. We plug this into our calculator and we get 1.248 moles of GaCl3. Any questions on that? Does it kind of make sense? See, this kind of confused me when I...
What was the answer?
Oh, I'm sorry. I should leave it on longer.
Thank you. The copy.
This confused me when I took AP Chemistry, okay? Because I'm like not that smart.
Yeah, we know.
There's a word to like describe how my brain works in chemistry, which I cannot say on screen, because it was. Oh wait, no, it's not that month. Oh, it starts with an R. But anyway.
Like the same word that like the same letter that your list starts with.
No, that's it. Ethan, we talked about this. Let's look at the next problem. Rapidly moving on. 2Cu NO3 plus 4Ki goes to 2GaCl3. All right. And what the heck? Oh, oops, I wrote the wrong. I need that Diet Coke button on the. Do you know Trump had a Diet Coke button on the White House desk? Every time he pushed the button, someone brought him a Diet Coke.
I'm in France, guys, with the Hana Roy.
Yo. You just graduated high school.
All right, so this is a weird problem. So we have 0.4388 liters of 0.3842 moles CuNO32. And we want to find how many liters of 0.2089 molar Ki we need to fully react. Okay, I'll be honest, I don't like these problems. So like, we're going to draw a picture with some liquid in it. This is the amount we start with. We start with this much CuNO32. So down here we have our 0.4388 liters of 0.3842 molar CuNO32. That's what we have starting in the beaker. And then we add in some extra fluid. And this fluid is Ki. And we know the concentration of Ki, but we don't know how much we have. We don't know the volume, the liters. So here's what we're going to do. We're going to find how many moles this is, and the amount of moles in here has to equal the amount of moles here. And then from there, we can use molarity to find the amount. So I know that made no sense that I said it all at once, but don't worry, it's going to make sense as soon as you see how it's done. So we start with, what if it doesn't? Then you can stay after class, Ethan. So what we do is we always start with what we're given. CuNO32, always. And now we have to get this to moles. How am I going to get this into moles? Oh my God, I'm on the exam and I don't know how the hell to get to moles and I'm stupid. I'm going to go to MCs. No, I'm not, just kidding. How do I do
There's some fireworks in the background. Can you give me a second?
If it's France, I don't think that's fireworks. I think it's something.
No, it's in South Windsor, Connecticut, 06074.
Great.
83 Jacques Lane or whatever.
Oh boy. All right, how do we get to moles? I have to use molarity. Someone want to pitch a guess? It has to do... Oh boy. Has to do with this up here.
You multiply by 0.3842 moles over 1 liter.
That's right. Because this, we can write it as 0.3842 moles over 1 liter. So we're going to put that in here. 0.384 moles of CuNO32 over 1 liter. So we finally got to moles of CuNO32. So that tells us the amount of moles in here. And to fully react, the moles of this has to equal the moles of this. So if we know the moles of this, we automatically know the moles of this. It's the same thing. So it's like we're jumping solutions. We're wall hopping, to say it in plain terms. And we're in moles, so to get over to Ki, we just have to look back at our balanced formula. And we see there's 4 Ki for every 2 CuNO32. So we're going to do 2 moles. So let's join the call. 2 moles of CuNO32 and 4 moles of Ki. All right, so we're finally in moles of Ki. We're up here. We're up here now. We know the moles in this, but we want to know volume. Fortunately, molarity can help us find volume too. By using this right here, this is the concentration of Ki. And we can also write this as a ratio. We have 0.2089 moles of Ki in 1 liter, or 1 liter over 0.2089 moles Ki. So now we're in moles of Ki. We want to get to liters. Which ratio should I use?
The first one.
First one? Yep. Because it cancels out, right? Wait. Actually, the other one. We're going to use this one. Not that one. Because moles is on top, and we want to cancel it out, so we have to put it on the bottom. So we go back and check our units. The liters of CuNO3 cancel out. The moles of CuNO3 cancel out. The moles of Ki cancel out, and we're left with liters. We plug this all into our calculator, and we get 0.161 liters of Ki solution. So that's the volume of this blue blob right here. And Ron, don't make me delete this recording again. Oh, man. If it's a naked man, maybe.
Put it back.
You see, Ethan, maybe if we weren't so busy looking at boys, we would be focused and be able to copy this down.
Yo, come on, Ethan.
You're the one that noticed it before I did.
Nah, I was writing. I was so focused writing my problem earlier, and then I look up and I see Satvik cracking up. And I'm like, oh, something must be going on. And then I look at Ram, and I'm like, oh shit.
Ram, put your dick away.
Bro.
Don't get it stuck in the zipper though. I don't want to deal with that.
Ram, the can still be used.
All right. Any questions on that? The last thing. All right. Anybody lost yet? Quick temperature check. I'll tell a joke to wake everyone up. How about that?
Yeah, let's hear it.
We'll have a theme here. Since Kevin was so
Yo, I have a joke.
adamant about talking about
who did Ahana Roy break up with?
what's that?
That's crazy.
Sharia
Roy?
Rajan.
Can I Google this?
Yeah.
Yeah, Google it.
Search up Ahana Roy breaking up with cancer patient.
Yeah.
Isn't that a doctor? Hold on. I have to look closer into this after class. I'm getting Hannah Roy, MD, FACP.
Yeah, that's her.
Let's do that. Oh, I don't know enough about that sort of stuff. All right, I'll tell a joke. Since Kevin and Ron were so adamant about talking about overweightness today, I'll make a joke. Your mama, and this is for those of us who are math freaks like me. Your mama is so fat when she got on the scale, it said divide by 0 error. Who got... I don't know if anybody gets it. You have to know math to really like math. You see, when you divide any number by 0, the answer goes to infinity. That's why.
No, sorry. I started laughing.
Can you
Like, that was
please
really
not
funny.
make fun of my mom?
Who's that?
Chris, someone.
Oh boy.
No way, Chris, someone.
This lesson, I apologize for this lesson. It's going everywhere. All right, next we're going to talk about complete ionic equations. Sure, tell quick.
Who here hates a certain type of people?
Ethan, there's not the time for that. Okay, I apologize to all my regulars. These are
Me.
Okay, we're gonna do the. Oops! Oh my God! What did I just click? I just clicked something random. Oops, my mistake. Okay, so we're gonna talk about complete ionic equations, which is a type of chemical equation. So you guys notice how this entire time I've been giving you these weird looking chemical equations, kind of like that one and that one, and like, like that one we had earlier, but I never really told you guys where these chemical equations come from. I never taught you guys how to write it. Well, that ends today. We're going to learn how to write these chemical equations from scratch. So there's two types. You have a complete equation. We have a complete equation which shows everything. Shows everything that happens. And we have a net ionic, which is an abbreviated version. You guys don't really have to know like the difference between the two, but just know that they exist. So in this class, we're only going to learn how to write these complete equations. This one is for AP Chemistry. Save that one for Miss Powell. So, we're going to, let me see here.
But I have a question.
Yeah?
So is this class for AP Chem or what is this?
This is the prep class for AP Chem, summer prep.
Oh, okay.
All right, so the reaction, there's many types of chemical reactions. And every single reaction, every category reaction has a different set of rules on how we write these equations. But today, I'm going to show you guys a very common reaction, and I'm going to show you the set of rules on how to do it. And when you guys master these rules, it will help you tremendously because so many reactions follow this pattern. This is called a double displacement reaction. And I'll show you what that means. AY plus BX equals to BY plus AX. That's the general term. But we notice here, A and B stay the same. But look what happened. Look what happened. We have a Y on the A and the Y on the B. We have the X on the B, but now it's on the, oh my goodness. Well, look, they switched partners. They switched partners. So we have this wife, this husband, and now they switched. They switched partners, just like the South Windsor High School English department. Did we hear about that scandal, like with Mrs. Who was it? Mrs. Doms and Mrs. Who's that other lady? Somebody's husband slept with somebody's wife. I don't know if people still talk about it. It was a big thing when I was at a high school. So I will publicly say this on camera. When we think of English double displacement reactions, think South Windsor High School English department. DEPT. There. Self-explanatory. No further explanation needed. Okay. So they switch partners, basically.
Justin,
Huh?
where's the fly swatter?
Oh, can this wait? All right, so let's see how it's done. Actually, I might need another sheet of paper for this. All right, so there's a series of steps, and I'm going to show you guys how to do it. Write the full equation when KOH reacts with FeNO3. Now, you guys might wonder, why did I make you guys do so many of those stupid crisscross problems on the 4th of July worksheet? This is why. It all comes back now. It all comes together. All right, so step 1 is to write the left-hand side of the equation. It's to write the left-hand side. We have KOH plus FeNO3. We literally just copy the two things we're given. This is the reactant side, the stuff before the reaction. We draw an arrow. Or when you guys get to Gautam, the other instructor in this class, a vector. We draw a vector showing the reaction. And everything on this side is the product side. So these two things react to produce something and something. But since it's a double displacement reaction, they switch partners. Now we just have to find what the subscripts are. So step 2 is to reverse crisscross. Who remembers how to do that? Somebody want to tell me how to do it? Pretend I don't know this. I shouldn't be teaching this class. So I want to reverse crisscross these two. I forgot. Keys to what? That's okay. Anyone else want to try? And we got Kevin chasing flies.
I got it.
All right. So we write the subscripts in, the numbers under. And what do? We take the numbers down at the bottom. We cross this shit back up. We cross this shit back up. And so on and so forth. We bring them back up. So step 2, we end with K plus OH minus. We get Fe plus 3. And NO3, the whole thing is minus 1. So far, so good? Now, normally, what we used to do, what I had you guys do in the first couple lessons, I had you balance right here, right? I had you add, like, numbers in front of them to make sure the numbers of ions are the same. Don't worry about that yet. Don't worry about that yet. Step 3, we're going to write the right-hand side. We're going to crisscross again, but we're going to switch partners. Then crisscross again. So we'll say this is Mrs. Dom's. This is Mrs. Dom's husband. This is Mrs. Flash. Mrs. Flash. No, she doesn't have a husband. This is Mrs. Who's the other teacher?
Vendetta.
This is Mrs. Vendetta. This is Mrs. Vendetta's a husband. So Mrs. Dom's is gonna gobble up Mrs. Vendetta's a husband right here. Okay.
Yo, this is helping me understand it a lot better.
And then Mrs. Dom's husband is gonna devour Mrs. Vendetta. Oh, I hope this was. This is not bring your spouse to work day. So hopefully this was under different circumstances. So we're gonna take K. We're gonna take. Someone say something in the chat. Oh no. All right, so we're going to take K and we're going to take NO3. We're going to cross them again. So remember, we cross this, bring this shit down, bring that shit down, and then we're going to take Fe plus 3. We're going to take OH. This comes down. This comes down. Just exactly like we did it before. So now we have the right-hand side, which gives us K, NO3, and FeOH3. So far, so good. We switched partners. You see how they switched? Up here, they were happily married, and now they are committing partner crimes. All right, so now the step 4 is to put everything together and balance. Now, here's where the balancing comes from. KOH plus FeNO3. This was the left-hand side that we found from step 1. Goes to NO3 plus FeOH3. Now we balance. Oh, great. I don't like balancing, but don't worry. I can teach it in a way that even stupid people like me can figure it out. So, all right, let's see. We start with, I noticed there are 3 OHs on this side and only 1 on this side. So I'm going to throw 3 here. But I messed up the K's. So I have to, where did that K? Oh, I'm missing a K here. I messed up the K's, so I have to add a 3 in front of the K's. But now I messed up the NO3s. But I look over here, and miraculously, there's already 3 NO3s, because God was looking out for us. All right? So, praise the Lord. All right, any questions on that?
Wait, what about electrons?
Oh, that's a different type of reaction. That's called a redox reaction. But
How about protons?
protons, you don't really. That's particle decay. That's alpha decay. That's physics.
Thanks.
All right, and your question, Ram. We are going to learn how to do the redox reactions this summer, how to balance those. But that's Gautam's portion of the class. The other instructor. I don't teach that part.
Wait, so like up till what date do you teach?
I teach up till class 8. Class 9 is when we switch instructors. So early August.
What
So
class
you
are you
guys,
on?
so if you guys don't like me, you guys can have Gautam to look forward to.
No, I love you, Kevin.
Completely different style of teaching, but still phenomenal. All right, any questions on this?
What class are you on?
This is class 4. All right, ready? Now there's another problem. I want you guys to try first before I go through it. Then we'll do it together. Where's the Diet Coke button? Ugh. This room has everything.
Better be waterfall.
Nope. I'm taking this room now. All this room's missing is bathroom.
Wait, you're in the bathroom doing this?
Nah, this is Kevin's desk.
Oh, okay. Thank you.
You're welcome. You see, Kevin, all Kevin has to do is install some public human waste collection receptacle facilities in here. Fancy way to say bathroom. Huh?
What was step 4?
Step 4 is it should be on the packet. Step 4 is to balance. Oh, you mean you want to see the problem again?
Oh, never mind. Now I'm chill.
And that's lecture for today. As soon as we finish this problem.
When's the next class?
What day is it today? Is it Monday?
When's the next
Classes are
class?
Mondays, Thursdays from 8:30 to 9:30. Sometimes we do go over, though. I try not to go over, but unfortunately, sometimes we do. There's lecture and problem solving. I know my lectures are all over the place sometimes, guys, but I appreciate you guys bearing with me. Gautam will not lose focus. I guarantee you that. He also won't get problems wrong.
Is Gautam like Gautam Chasmawala?
Yeah, Gautam. Do you know Gautam Chasmawala?
Yeah, I know him.
How do you know him? Family friend?
First of all, that's racist. Second of all,
I'm sorry
know
for
him-
anyone
I
who's
know
working
him
right now who
because
has
I used
to.
to have a Java class with him.
I'm sorry for anyone who's focusing and having to listen to this. You can mute me if you don't want to listen to this, and I'll tell you in the chat when to unmute again. Wait, so you used to have a job with him?
I used to learn Java with him. He was my tutor.
For what? Like Jumpstart, NHS?
No, it was like this, like a summer class, you know.
That's very got him. So, was he a good teacher?
No, he was ass.
Oh, thank God I told everyone to mute this. Hey, ruined my business. Nah, he's fine. He's fine. Listen.
Oh, my bad. Sorry for swearing. I'll make sure to keep my language family friendly.
Listen, no, got him knows his stuff. And I know this, my portion of this class, once we get to lesson 6 and lesson 7, there's going to be a lot of math in this class. So Gautam's portion is easier, much easier than this portion of the class. So don't worry if you guys are like, huh?
So even with the worst teacher, it's the same difficulty.
Yeah.
Also, the fly came back alive, so I had to get it a second time.
Justin, I just want to apologize for swearing too.
Nah, that's okay. Although there are elementary schoolers in this meet.
I'll make sure not to do that again. Keep it family friendly.
Yeah, don't do that shit again.
And for you guys to know, this class was actually my... I know that on the flyer, it's me and Gautam's face hanging on Miss Powell's door. We both collaborate on this, but originally I was the one that started this, and I had to find someone else to help me teach. Fortunately, Gautam was the smartest. What the hell is he doing? Is he... Oh, never mind. I thought he was doing something else. For a second, I thought he was in the bathroom, the way he was standing.
Yo, that's Krish's fat ass brother. His name is Keith.
Rom, can you not swear again, please? Thanks.
All right. All right, so it's about to kick me out. The meeting has a 1 hour time limit, so I'm going to try to do this problem out. After this, we're going to go into the problem solving, the worksheet portion. I'll send an extension link. After this, we finish lecture. You don't have to stay if you don't want to, or you have other commitments, but I will go over the worksheet problems too. All right.
Are you going to post the answers to the worksheet
I
after?
post the answers, yeah. All right, so we're going to write the left-hand side. This was step 1, really. That's the left-hand side. Step 2 is reverse crisscross. Can 3. Can somebody reverse crisscross this for me?
Well, I ain't doing all that.
So we're going to bring... This is a 1 here, really. This whole thing is 1 unit because it's a polyatomic. Bring that up, bring that up. I know I'm going fast, but I want to beat the clock. So we get K plus and 4 minus 2, and then BA plus 2, NO3 minus. Step 3, Mrs. Doms. All right, so we have K plus pairing with NO3 minus, and we have BA plus 2 pairing with, where is it? CrO4. Minus 2. How are we doing on timing? All right. All right, we're going to crisscross these again. We get K, NO3, BA2, CrO4, 2. And since they're both 2s, we can cancel them out and just get BaCrO4. And then step 4, put them all together and balance. So we have K2CrO4 plus BaNO3 2 goes to KNO3 plus BaCrO4. All right, now we balance. There's 2 Ks here, so I'm going to throw a 2 on the K, but I messed up the NO3, so I gotta throw a.
You got like not even a minute left.
Oh wait, no, that's balanced.
You got less than a minute. Good luck.
All right, there's the answer. All right.
Stop the recording.
Yeah. All right. I'll send an extension link if you guys want to come back. Otherwise.